Good evening.
Good evening, sir.
Good evening, sir. Yeah, good evening. Good evening. Good evening, please. Last class நம்ம இதுல ஸ்டார்ட் பண்ணோம்னு நினைக்கிறேன். Stephen reduction ஓட ஸ்டார்ட் பண்ணோம். கரெக்ட்டா? And we'll start with Stephen reduction. It's a preparation of special preparation of aldehydes from nitriles. Aldehydes can be prepared from nitrile itself by Stephen reduction. Stephen reduction. The Stephen reduction means the Stephen stannous, I told you, STANNOUS, stannous chloride. Stannous chloride, HCl. So the reaction will be conducted in acidic medium. Okay, in acidic medium we are conducting. SnCl to HCl we can use it. Okay. Say for example, if you consider CH3C triple bond N. What is the name of this compound? Anybody know this?
Alkyl cyanide, sir.
Alkyl cyanide. Okay. Any other thing? So specific IUPAC nomenclature. It's a common name. Commonly you say that it's alkyl cyanide. Very good. But generally we can't say
Methyl,
this
sir.
as a cyanide group.
Acetonitrile.
Acetonitrile. Acetonitrile. Is it acetonitrile? Okay, fine then. Any other thing? Ethyl nitrile. Okay. So why it will be called as nitriles? Why CN group will not be called as cyanide here? Why it is called as a nitrile here?
So because there's a linkage with hydrogen and carbon, sir.
Sorry?
There's a linkage of bond with hydrogen and carbon, sir.
Hydrogen and carbon. Okay, so where the carbon and hydrogen bond is there? What your meaning? Whether this carbon or this carbon?
So the carbon of the CN, sir. CN group, sir.
CN. Where it has a bond with the hydrogen?
So H3 bond is there, no, sir?
That is directly bonded with the carbon. The carbon
yes,
only bonded with the hydrogens.
There's a bond linkage, no, sir?
Yes. H will be like this. Okay. Okay. Then
there's a bond linkage, sir.
Bond linkage.
And sir, two nucleophilic centers are there, sir. Carbon one, this one and this one. Two nucleophilic centers are there, no, sir?
Okay. Okay. Fine. So when CN group is attached with any metals, it will be acting as an ionic compound. That is ionic compound. In that ionic compound only it will be acting as cyanide. So the effect of a cyanide ion will be very less when it is attached with any alkyl. So then only it is called as a nitriles. Okay, nitriles. So the activity of CN group is very, very less if it is attached with a non-metal. If it is attached with a metal, activity will be very high, then it is called as cyanide. But here it is metal. So whenever the carbon is attached with the cyanide group, that will be otherwise called as nitriles. Okay. Right. So here ethyl nitrile, which will be reacting with the SnCl2 and HCl. So what kind of product I can get? Initially, I can get some intermediate product like this: CH3, CH double bond NH. So this is nothing but imine. Imine. So once I got a imine, if you got a imine in presence of an acid, if you hydrolyze it, I'll get my product CH3C double bond OH aldehyde I can get, along with that ammonia. So this is the overall reaction of this one. So ethyl nitrile in presence of SnCl2 and HCl, so it will form initially imine as a product, byproduct or intermediate. So from that, if you hydrolyze the intermediate, you will get, what is that? Aldehyde as a product. Okay. So this is a simple reaction when SnCl2, which will be reacting with HCl, it forms SnCl4. SnCl4 along with that 2H+. If 2H plus are eliminated, so 2 will be here. So what about oxidation state of tin in SnCl2? Oxidation state of tin in SnCl2 and oxidation state of tin in SnCl4. This is 2 minus, so Sn2 plus is there. This is 4 minus, this is 4 plus is there. So Sn2 plus become Sn4 plus. Sn2 plus is going to become Sn4 plus. What kind of reaction is this? Oxidation. If it is an oxidation, there will be a elimination of electrons. Okay. So likewise, now our electrons which are going to react with our reactant. Our reactant is CH triple bond N. That is going to react with the 2 electrons. What it forms? So it forms like this. So usually we know that the nitrogen will, the electrons will be, 2 electrons will be shifted over here because nitrogen has higher electronegativity than carbon. So what will be my here CH3 C here plus double bond N minus. Okay, is that clear? One positive charge, one negative charge is there. Along with that only we are going to react with our 2 electrons. It will be react with the 2 electrons. Now what it will form? It will form CH3 C double bond N and also with 2H plus. Am I right? 2H plus ions. What about the 2H plus ions? Are you able to understand this or not? Instead of which one more step is there. If it is reacting with the 2 electron, what it will form? The positive charge is getting neutralized. Okay. At the same time, the carbon is observing one more electron because the 2 electrons are coming and attacking. Here, CH3, C minus and N minus will be there. Okay. In this, now our 2H plus which is going to react with this 2H plus are going to react to form CH3 CH. 1H will be added here, 1H will be added here. CHNH. Here double bond is existing. Okay, we know that this is a double bond because we missed double bond here. So this is what our imine. So I got from the imine as my product. So we know that this is a imine product. CH3 CHNH. Double bond NH, CH3 CH double bond NH. That is my imine. So once I got a imine as a product, after that my further step will be like this. When CH3 CH double bond NH will be there, and that is going to react with the H plus ion. If it is reacting H plus ions means these 2 electrons will be shifted over here due to higher electronegativity of nitrogen. So then what I will get? CH3, C here positive charge, single bond, and here I got negative charge. This H plus will go and attack here. So then what will be my is already NH is there, NH minus and H plus is there. Then CH3, C plus charge is there. Then NH minus on H plus is attaching, so NH2. Okay. So once you got this, you can hydrolyze it. So if you hydrolyze it, you have to add water molecule. So water has a lone pair of electron that can be donated to this carbon. Then CH3, C here O, H, H here positive charge. Why here oxygen getting positive charge? Because it can donate electron to the carbon. Then again NH2 is there. So just written NH2. Then what will happen? Oxygen is highly electronegative, but here positive in nature, so that it try to become it can donate electron, 2 electrons to this. It can donate 2 electron to the oxygen and left over as H plus. So minus H plus. H plus will be removed. Then CH3 COH and here single bond NH2 is there. And with that ammonia also, now we are having lone pair of electron. That lone pair will approach this lost hydrogen that can absorb the lost hydrogen from the previous step. So CH3, C here OH, here NH3. Because of donation of electron, it got positive charge. Is that clear? After that, what will happen? So let us write like this. OH group like this. OH. Now oxygen is highly electronegative. It can pull the electron towards to this. So it attains negative charge. It attains positive charge. Okay. Then what will happen? H plus will move off. Minus H plus. H plus will move off. If H plus will move off, now this oxygen will getting negative charge. This oxygen is getting negative charge. Am I right? Once the oxygen is getting negative charge, it can try to pull back. That means due to the vibration, it can donate electron to this. So now the carbon will cleave this bond. Okay. So what will be my product? CH3, C, already one H is there. Okay. So in all the places one H is there. Am I right? Here we also need this H. One H is there. One H is there. H is there. So now CH3, C, double bond O, and H is there along with that NH3. Ammonia is getting left out. Then initially we used some acid that also getting regenerated. Okay, this is what the reaction mechanism of what is that? Stephan reduction. Very, very important reaction. So just you should know the reaction mechanism also, because the questions may come from this area also. Okay, this time we can expect, especially because they are going to give you in terms of MCQs. Okay, MCQ questions will be like this only. So in that mechanism also they may ask questions. CH3, CH2, C triple bond N. Then if I react with SnCl2 HCl, okay, along with the acid and water, what will be my product? Can anyone
Propanol.
say?
Propanol.
Propanol. Very nice. CH3, CH2, CHO. Along with that, ammonia is getting left. Okay. So likewise, our product will be reduced. Okay. And next one is a very, very important reaction. We can use some other things like instead of R, C double bond O, Cl, instead of R, C triple bond N, okay, or R, C double bond O, R. All these things can react with a single reagent to form a same product. Okay, so if it is react with what is that? Do you know this dibol H? Dibol H. Did you heard about this dibol H? What is dibol H? It's nothing but diisobutyl aluminum hydride. Diisobutyl aluminum hydride. We know that isobutyl. What is isobutyl group? CH3, CH, CH3, CH3. This is what isobutyl group. Am I right? So the diisobutyl aluminum hydride like this. So aluminum we have, and we have one more hydrogen, and now the entire group will be attached with isobutyl. And they say diisobutyl, so we can put it twice. This is what the structure of diisobutyl aluminum hydride. Diisobutyl aluminum hydride. It will be written like this also. Al, and here H, and here yeah, it will be like this. This is also diisobutyl group. This is a isobutyl group. This is a one isobutyl group. So diisobutyl aluminum hydride. This is what the structure of diisobutyl aluminum hydride or dibol H. So here the importance of this reagent is what? So here we can able to prepare aldehyde from acid chloride. What is the reaction? Last class we discussed
Rosenmund, sir. Sir,
Rosenmund, very nice. So here we are in need of Rosenmund reduction to some reagent like palladium, barium sulfate, hydrogen, that kind of reagents we need. And from that RCN, if you want to convert aldehyde, what I have to use? Today we saw that. What is that? Stephen reduction. Okay. But here, both the reactant is not required. Only dibol H will convert that acid chloride and what is that? Alkyl nitrile into aldehyde. Okay. So because this is a mild reducing agent. So when compared to lithium aluminum hydride is a strong reducing agent, but here it is a weak reducing agent, or we can say mild reducing agent. If it is a strong reducing agent, if I use RCOCl, I will get alcohol as my product. If I use ester, then alcohol as my product. Okay, but here, suppose if I use here a strong reducing agent, I can get what my product is. It may be alkene is my product. But here, if you use dibol H, there will be a partial reduction will be there. It will be acting as a mild reducing agent to convert RCOCl into aldehyde. The overall product will be like this, RCHO. I can get the product like this. Okay, so instead of using Rosenmund reduction or Rosenmund reagents, or instead of using Stephen reduction, we can use dibol H also to convert alkyl cyanide or alkyl nitrile or acid chloride or ester into aldehydes. Okay, right. And this is a wonderful reagent. And next one is from oxidation of methylbenzene. From oxidation of methylbenzene. Methylbenzene means what?
Toluene, sir.
Yeah, toluene, right? Toluene. So here a benzene ring and one methyl group is there. This is what a toluene or methylbenzene we can say. From that toluene, they can use some strong oxidizing agent. Like if we use KMNO4, what will be my product?
COOH, sir.
Very nice. Benzoic acid as my product. Okay, if I use this KMNO4, I'll get benzoic acid as my product. But if we use here some weak oxidizing agent, or weak oxidizing agent, what kind of things I can get? So either CrO2Cl2 chromyl chloride or CrO3 chromic acid and acid anhydride. Chromic acid anhydride. Sorry, COCH. Yes, acid anhydride. If I use this, I can get benzaldehyde as my product. So the partial reduction will be taken. Sorry, partial oxidation will be taken. Okay, half of the oxidation reaction. So mild oxidizing agent we can say. These are all the mild oxidizing agent or weak oxidizing agent. Weak oxidizing agent. But here it is a strong oxidizing agent. If we use strong oxidizing agent, the CH3 group is completely converted into carboxylic acid. But here we are in need of preparation of aldehydes. That's what we have to use mild oxidizing agent. Okay. So here also the reaction mechanism is not that much important. Sometimes they may ask. So if they ask, we'll see. If we need, I'll write always, no problem. Just we can skip the mechanism also. So here methyl group, that is toluene. So suppose if I'm taking CrO2Cl2, and that is going to react in presence of carbon disulfide because it is a non-polar one. So that I have to use some non-polar solvent to dissolve this. Okay. So carbon disulfide will be acting as a non-polar solvent. Once I use this, I will be getting my product like this. So intermediate product will be like this. CH, here O, CrOH, Cl2. Here O, CrOH, Cl2. If you can't understand, there is no other way. We have to go with the mechanism only. Okay. So here H3O plus, if I use it, so I'll be getting my product like this. CH, here OH, here OH. In a single carbon, 2 OH group is there. So it can try to lift as water molecule. So then what will be my product? It can lift as OH minus. It will lift out as OH minus. So it gives positive charge. Here H plus will be removed. So O minus will be there. These minus and positive will form a double bond here. So then I can get my product like this. C double bond OH. Aldehyde, benzaldehyde as my product. Very, very important reaction. This reaction is named as Etod reaction. Etod reaction. So the conversion of methyl benzene CH3 group into CHO. So conversion of methyl group into aldehyde. The reaction, one of the reaction is Etod reaction. Very, very important reaction. And one more reaction will also be available. So when the same toluene will be taken and the reagent will be changed, CrO3, then acid anhydride, that is CH3, C double bond O, OC double bond O, CH3. This is an acid anhydride. Once it is react with this, I'll be getting my product like this. CH and here OC double bond O, CH3. OC double bond O, CH3. I think so. You have a doubt how this entire group is getting attached. Okay. How the entire group is getting attached here, sir. This is very, very simple reaction. I will explain you. So just I'm taking a toluene molecule and here CH written and one of the H will be written here and one of the another H will be written here. Can write like this. Then we have to write CH3 C double bond O C double bond O CH3. Here also 2 moles of CH3 C double bond O C double bond O CH3. Okay. Then what will happen? Then what will happen? So the entire group is getting attached here. So here carbonyl group will be getting stabilized and it will provide one electron here. And this electron, this bond is going to break it. Because this reaction will be undergone presence of light. The reaction will be taken place in presence of light. So the homolytic cleavage will be there. If hydrogen is breaking, these two electrons are there that can get breaked out. And this hydrogen will take out this electron. So this electron is here. And this carbon will be taking out this electron. This electron is here. Okay. Now just we can react this. This hydrogen will go and attach with this carbon. This will be attaching with the carbon because both are free radicals only. It can straight away can attach with that. So what will be my product? CH3 CH CH3 C double bond on H is there. So I'll be getting formed as CH3 CHO like that. And one more thing, the same reaction will be proceed here also. This hydrogen will take away this electron, that electron is here. And this carbon will take away this electron, these 2 electrons are here. Now this hydrogen will go and attach to the same carbon. So these 2 dots are combined to form 2 molecules of acetaldehyde. 2 molecules of acetaldehyde. The remaining 2 things are what? So this dot is going to attach with this dot. And this dot is going to attach with this carbon, this oxygen. Okay. Like this also in the same color. It will be better for understanding. Now this single dot and single dot will form a bond. Okay. Now what will be your reactant? So the same product here, this kind of intermediate product will be there. So CH is there. Along with this carbon, one O is attached. So one O is attached. To the O, one carbon, one CH3. To the O, one carbon, one CH3. Likewise, the same thing. Oxygen attached directly with this carbon. Yes, oxygen attached directly with this carbon. Then CO, CH3. Okay, CO, CH3 group is there. Okay. I think so. You can able to understand how the entire group will be attached. Here also the same thing. CrO2 Cl2 will going to attach like that. Okay. So if I do this, so then what will happen? I have to like to hydrolyze this H2O. So we have to hydrolyze it. How the hydrolysis will be taking place? So here we know that if this bond is getting break out, you consider this will have slight negative charge. Why? Because oxygen is highly electronegative. So then it has slight positive charge. Now this bond is going to break. So because oxygen is highly electronegative, it has negative charge. Here the carbon has positive charge. Okay. Now we know that 2 moles of H plus and OH minus will be there. So in water. So this OH minus, O minus will be there. So this O minus will approaches this hydrogen. So then it becomes CH3COOH. It left us CH3COOH. And here it leaves positive charge also. Here I have a positive charge. And here CH3CO plus is there. And this will approach this OH minus. So here also one more molecule, that is 2 moles of CH3COOH will be going out. And here I got negative charge. Okay. So what is our final thing? So here I got positive charge. Here I got negative charge. That's it. Okay. All the remainings are getting breakdown. Now this electron will shift over here to form my product as benzaldehyde. C double bond O H is my product. This is what I get formed benzaldehyde as my product. Is that clear or not?
Yeah, we'll get byproducts as well, right?
Yeah, we are getting a byproduct like aldehyde is a byproduct, carboxylic acid is a byproduct. After that, main product is what is that? Benzaldehyde. Okay, so we can get able to prepare 2 different aldehydes also by this method. Okay, so this is a chromic acid anhydride reaction. Is that clear or not?
Clear, sir.
Next one is a side chain chlorination. Side chain chlorination. Side chain chlorination means followed by hydrolysis. Okay, so in all the cases, followed by hydrolysis will be there. So as we know that when methyl group is attached, CH3 is there, and if it is involved a reaction with Cl2 in presence of light, what will happen? Generally, in presence of light, when chlorine is getting react with a hydrocarbon, what will be our product? Normally, monohalogenated product only formed. Am I right? Monohalogenation or monochlorination only the product. So according to that, I should get CH2Cl. That will be my product. Okay. But actually, here it is not like that. Because it is a benzene ring, it can try to pull the electron from that carbon. Now carbon is getting more positive charge. So if no more positive charge means the chlorine will go and attach to that. So I'll be getting formed these kind of product. CH, here one Cl, here one Cl. After that, if you do hydrolysis, H2O, let's take H plus OH minus. What will happen? The HCl will goes off, H plus OH minus. HCl will goes off. So then what will be my product? The same thing. In a single carbon, I get formed the 2 OH group. Now it is highly unstable. It left as OH minus. It can leave as H plus. So if it is H plus, it can give an electron. If it is leaves OH minus, it can pull the electron from here. So it got positive charge with negative charge. This positive negative will form a double bond. Then I'll get my product like this, benzaldehyde. Benzaldehyde as my product. Okay, this is what a side chain chlorination. So whenever you want to convert this methyl group into aldehyde, you have to use these 3 methods. What are all the 3 methods? Either etard reaction or otherwise we can use chromic acid anhydride. Etard reaction in the sense a chromyl chloride. Okay, and chromic acid anhydride we can use it, or otherwise we can use what is that? Side chain chlorination. These are all the 3 important reaction for converting toluene into benzaldehyde. Toluene into benzaldehyde. Okay. Another reaction is also be there. from Gatterman-Koch reaction. Gatterman-Koch reaction. So what is the Gatterman-Koch reaction? This reaction will otherwise called as a formylation reaction. What is that? Formylation reaction. Sometimes they may be asked in the question paper, write the reaction of formylation reaction method. Okay, that time I should not get confused. That is nothing but a Gatterman-Koch reaction is otherwise called as formylation reaction. Okay. So here, what are all our reagents? That is very, very important. So here, just I'm taking a benzene along with that CO, along with that HCl, along with that I have to take some catalyst like AlCl3 or CuCl. So if you use, I'll be getting my product aldehyde. Okay. From benzene to I can able to prepare benzaldehyde by Gatterman-Koch reaction. So initially our two reactants like C double bond O, which will be reacting with HCl. Then what is my product? So here oxygen is highly electronegative and here it is positive. Here hydrogen is positive and chlorine is highly electronegative. So this chlorine will approach here and hydrogen will approach here. So then what will be my product? So I'll be getting C, OH and Cl is here. And here also it will involving in some rearrangement. It will form like this H, C double bond O, Cl. Okay. Is that clear? So this electron will be transferred to this. So the carbon and hydrogen is getting formed a bond. So if carbon and hydrogen is getting formed a bond and the H plus, okay, H plus will come and attack here. That's it. So if H plus will come and attack here means here it has negative charge. This negative charge will approach and that can donate electron to this. I'll get formed HCOCl. This is called a formyl chloride. Formyl chloride. It is highly unstable. Highly unstable. Why it is highly unstable? Because there is no donating groups are there. In Rosenman reduction also we talked about this, right? So formyl chloride is a highly unstable one because there is no other donating groups are available to stabilize this, because oxygen also lone pairs are there, chlorine also lone pairs are there. So there is a lot of repulsions there. That's what they are going to become highly unstable. Okay. So if it is highly unstable, so it will involving in electrophilic substitution. So now AlCl3, we know that it is a Lewis acid. It is a Lewis acid. Lewis acid means what? What do you mean by Lewis acid?
Sir, it helps in the cleavage of the carbon-oxygen bond.
Okay. Any other thing?
Forward reaction, sir.
Okay. Lewis acid. What's the definition for Lewis acid? We know that many concepts are there. I mean, right? Bronsted-Lowry concept, Arrhenius concept, Lewis concept. We have a number of concepts you studied in 11th standard also. So Lewis acid means what? So it can try to accept electron pairs. The electron pairs acceptors are nothing but Lewis acid. Electron pair donors are called as Lewis bases. Okay. So here AlCl3 will try to accept electrons from where? From HCOCl, HC double bond OCl. It will try to give electron because where the electrons will be there, the chlorine will donate electron to this AlCl3 and the AlCl3 will try to accept electron. That is going to become AlCl4 minus. If the chlorine will get lost from here, the Cl minus will be there because chlorine is highly electronegative than carbon. It can cleave the electron along with that. So it can leave positive charge. So I'll get C double bond OH and positive charges exist. Am I right? This is my electrophile. Once I got this electrophile CHO plus, then it is reacting with our reactant. What is another reactant is missing here? Now in the first step, HCl, CO is reacting. In the second step, formed HOCl and AlCl is reacting. What about the remaining has to react? What is the remaining thing? It has to react with CHO plus.
Sir, H3O plus, sir.
Plus CO HCl react ஆயிடுச்சு. React ஆயிதா HOCl ஃபார்ம் பண்ணிருக்கு. ஃபார்ம் ஆன HCl செகண்ட் ஸ்டெப்ல AlCl3 ஓட ரியாக்ட் ஆயிடுச்சு. அப்ப இவங்க ரெண்டு பேரும் ரியாக்ட் ஆயிட்டாங்க. வந்த ப்ராடக்ட் இவரோட ரியாக்ட் ஆயிட்டாங்க. What about the remaining thing? Only thing benzene is existing. So as we know that here electrophile form ஆயிடுச்சு அப்படினாலே electron rich species தான் தேவை. Electron rich species means what? Benzene ring. Okay, then now the benzene ring which is going to react to this CHO plus electrophile. So 1, 2, 3, and one more thing, C double bond O H and positive charge is there. என்ன நடக்கும்னா? Any idea? Any idea from anyone?
So the carbon oxygen bond one breaks, sir, because partial double bond stay there, sir. So CHO will go there and one hydrogen will be liberated, sir.
Hydrogen will leave. Okay. Any other thing? Because it will be existing as electron deficient species. It will be existing as electron deficient species. It will try to accept electron from somewhere else. So where the electrons can get it? From where it can get electrons?
Sir, oxygen,
And
sir.
the para
Not like that. Not from oxygen.
from benzene.
Because oxygen is highly electronegative. Oxygen is highly electronegative. And I can try to pull the electron from here, from the carbon itself. Okay. So that is not possible. So then any other reaction, any other where getting electron from?
Sir, can it get from benzene salt or para?
Yeah, that's it. Because from the benzene only the reaction will proceed. Why? Because the double bond is there. Double bond in the sense one single bond is called sigma bond. If a double bond is there, one sigma bond and one pi bond is there. The pi bond is weakly held at one. You can easily cleave the electron and can leave the electron to form bond. So now this electron will be shifted over here. Now what will be our thing? So இப்படி இருக்கும் 1, 2, and here I got negative charge, and here I got positive charge. Okay. Now this negative charge will go and approach this electrophile. So it can try to attract. So it attracted this C double bond to H. The entire thing is getting directly attached to this. And here double bond, here double bond, here positive charges. In the next step, what will happen? Anybody? We already discussed in 2 chapters about the reaction mechanism of what is that? Electrophilic substitution. I can give you the clue. So it has to become an aromatic compound. It has to become an aromatic compound. If it want to become an aromatic compound, what is the important requirement for this?
So the carbon should be stabilized, sir.
Carbon should be stabilized, which that should be, that is the ultimate aim. How it should be stabilized?
Resonance, sir.
Resonance. Okay. Any other thing? Very good. Where can get electron? How the electron is getting transferred, or how the triple bond is existing? So one more bond has to form here. How it can form a bond?
So we remove one hydrogen from the benzene.
From where? From where?
From where the C double bond aldehyde group is there, sir.
Very nice. So that is a reaction mechanism. Because once the CHO will come here, the H plus will wants to leave on its own itself. The CHO ulla vanda odane enna aidum H plus வெளிய போகும். Because this carbon is getting more than 4 bonds upper cleaved. So now this electron, it has one electron. That 2 electron will be transferred here. The entire thing is getting satisfied and double bond is getting formed. Very good, man. Nice. So here C double bond OH. Benzaldehyde has been formed. Okay. Very, very important thing. From benzene to benzaldehyde, straight away we can do by using Gatterman-Koch reaction. Okay, so that's all about the preparation of aldehydes. Okay, there's a special preparation of aldehydes. And next one is the preparation of ketones. So this is also a special one, ketones only preparation. So ketone preparation only, ketone only preparation we can write, ketone only preparation. Specifically by using some reagents, we can prepare ketones. So that is what we are giving in a separate one. First one is acyl chloride. Acyl chloride. From acyl chloride, we can able to prepare aldehyde also. That is a Rosenman reduction. That's the first special preparation of aldehydes. But here we are not going to use any reagent like a Rosenman reduction. Okay, so here also we have to do some reduction, but we should reduce it with mild reducing agent. We have to use some mild reducing agent. So this is what the mild reducing agent like CD or CD or CDR2 we can say. This is nothing but a dialkyl cadmium. Dialkyl cadmium. Did you heard about the cadmium metal? Cadmium. Where it is used?
Catalyst, sir.
Catalyst, very good. Catalyst, a good application. Catalyst, it can act as a catalyst. Very good. Did you heard about this word 916 KDM?
No, sir.
916 KDM. You didn't heard about this? 916 KDM. 916 KDM gold. நகை கடையெல்லாம் போட்டிங்க போய் பாத்தீங்கன்னா எழுதிருப்பாங்கப்பா 916 KDM gold அப்படின்னு எழுதிருப்பாங்க. 916 is nothing but 91.6% gold. Again 7.4%. 7.4 தானே? ஆமா 7.4 8.4% of copper. So அப்ப நம்ம யூஸ் பண்ணக்கூடிய pure gold கிடையாது. So it's an alloy. You know that. So 8.4% of copper and 91.6% of gold. Pure gold will not be used to make ornaments. மாதிரி எந்த விதமான நகைகளோ எதுவும் செய்ய முடியாது. So we have to use some copper. Then only the malleability, ductility property will be improved. Then only we can do jewelries. And then KDM. So KDM is nothing but a cadmium. It will be acting as a fusing metal. Then the சின்ன minute works எல்லாம் பண்ணுவாங்க. அதெல்லாம் பாத்தீங்கன்னா அங்க ஃபியூஸ் பண்றதுக்காக என்ன யூஸ் பண்ணுவாங்கன்னா cadmium metal யூஸ் பண்ணுவாங்க. Okay. So இந்த மாதிரி யூஸ் பண்ணுவாங்க. So then acyl chloride will be reacting with dialkyl cadmium. So when the dialkyl cadmium is reacting, I will be getting formed the ketone as my product along with that RCD. What is that? Cl like that. Say for example, acyl chloride RC double bond to Cl I can take. This is the acyl chloride and RCDR I can write like this. Nothing but very simple reaction. When Cl is getting attached here, then R will be attached. Okay, so we know that here R will be getting negative sign. Why? Because it's a metal 2+, and here also this R will getting negative charge. This negative charge will go and approach where the more positive charge is there, so it will be getting approached. So where will be the more positive charge? Because oxygen is highly electronegative. Here chlorine is highly electronegative. So both of them will pull the electron from carbon. This carbon. So now this carbon getting more positive charge. So this R- will go and approach here. Then what will be my product? RC double bond to R. So I get formed the ketone as my product. Along with that, CD2+ is there and Cl is there. So RCDCl is there. Okay. So likewise, we have to use. Okay. And here it's like to be a Grignard reagent or MgX here RCDR. That's it. So it is what? It is a somewhat strong reducing agent. Strong reducing agent. Which one? Grignard reagent. We know that, but here it is a mild one. Okay, for that mild one only we have to use to prepare ketone as a product. Okay, from dialkyl cadmium, I can get formed the ketone as a product. Okay, and from nitrile, we already discussed about this in aldehyde itself. So, say for example, CH3CH from nitriles. So, likewise, we prepared in aldehyde, we can also prepare ketones also. So here, when it is reacting with Grignard reagent or MgX, we already written about this mechanism also in RMGX in the last class. Okay. What will be our product? My product will be like this. There is CH3, CH2, C double bond O, and R will be there. Then I'll get formed the NH3 ammonia as product, then Mg, here OH, here X is my product. Okay, these are all the byproducts of these reactions. Okay, so from nitriles also we can able to prepare these kind of ketones. Okay, and next one is from benzene and substituted benzene. We know that from benzene. But from benzene, how we can prepare ketones?
Friedel-Crafts acylation, sir.
Very nice, very nice. From benzene we can take, so the benzene is there, and along with that R, C double bond O, Cl. So ketone venuna enna pannanom? So we have to prepare like this. So the C double bond O, R. Okay, along with that HCl. I'll get formed HCl. You know that. So this is a anhydrous aluminum chloride. Every form of reaction, very simple. When R, C double bond O, Cl, which will be reacting with AlCl3. We know that AlCl3 is a Lewis acid. It can try to accept electron from chlorine. So R, C double bond O plus is my electrophile. Then AlCl4 minus. Now R, C double bond O plus is there. That is going to react with C double bond O R plus. So as we know that this bond is getting breaked very easily to form these kind of resonating structure. So 1, 2, and here negative charge, here positive charge is there. This negative will go and approach C double bond O R plus. So then my product will be like this. So 1, 2, and here C double bond O R. Once the C double bond O R is there, okay, there will be a leaving of hydrogen will be. Okay, that hydrogen will donate 2 electrons. These 2 electrons to this carbon make it aromatic. Did you know the conditions for aromatic? Anybody can say what is the condition for aromatic compound? How will you identify whether the given compound is aromatic or not?
So the number of hydrogen should be less than the number of carbon atoms.
Okay, number of hydrogen should be less than that of number of carbon atoms. Okay, if it is an equal,
Equal means
C6
benzene, sir.
H6, C6 H6, whether it is aromatic or not?
Yes, sir.
Why? You said that the number of hydrogen is should be very less than that of a carbon. That's what I asked. Okay. Okay. So if it is equal, will also be there. Okay. So what is the condition for aromaticity? If the compound wants to be aromatic, what all the conditions should be there? Say for example, you consider whether whether this compound is aromatic or not. Whether this compound is aromatic or not. So you have to check some condition. What are all that? If the compound wants to be aromatic, it should be cyclic. Yes, first condition is satisfied. It is cyclic. And one more thing, there will be a conjugation should be there. Conjugation means what? Double bond, single bond. So double bond is here, then single bond. Then positive charge is there, then single bond, then double bond. Okay. So likewise, it's rotating continuously. Okay. So conjugation will also be there. Okay. Hyperconjugation rules. Conjugation will also be there. And it should follow 4n plus 2 pi electron rule. 4n plus 2 pi electron rule. Okay. It should follow pi electron rule. Okay, Kana, no problem, no problem.
Sir, is phenol cyclic, sir?
Sorry, which one?
Phenol, sir. Is it cyclic?
Yeah, phenol is cyclic only. This is a phenol. Cyclic only. Phenol is aromatic only. 4n plus 2 pi electron rule it has to follow. So if n equal to 1, what will happen? What is the total number? 2 pi electron. If the compound has 2 pi electron, that is coming under the category of aromatic. If n equal to 2, what about that? 6 pi electrons. Then compound will be aromatic. If n equal to 3, then what happened? 4 into 3, 12, 14 electrons. Am I right? Or sorry, n into 3 means 4 into 3, 4 into 2, 4n plus 2 pi electron rule. So what about that? If n equal to 1 means, sorry, n equal to 1 means 4 into 1 plus 2. So 6 pi electrons. Am I right? 6 pi electrons. If n equal to 0, then 2 pi electrons. If n equal to 2, 4 into 2, 8 plus 2, 10 pi electrons. Then 14 pi electron system. So likewise, 2 pi electron, 6 pi electron, 10 pi electron, 14 pi electron systems. And also it should be cyclic and it should have conjugation. Moreover, it should be planar in structure. Planar. That is experimentally known. So we should not consider that. Planar. Okay. So if satisfied all those conditions, it will be aromatic. So according to this system, there is a 2 pi electron system. It is cyclic conjugation, so it is aromatic. Okay. So if we consider like this benzene 1, 2, 3. So it also forms 4n plus 2 pi electron rule. Conjugation is there. Then cyclic compound is there. So 4n plus 2 is 6 pi electron is there. So it is aromatic. Okay. So likewise, we have to find whether the given compound is aromatic or not. The next one is, so now I can give you some questions. Hexane 1 all. I have to convert this into hexanal. What kind of reagent I can use?
Sir, PCC,
Whether
CRO3, sir.
it's oxidizing agent or reducing agent?
Oxidizing, sir.
Very
PCC,
good.
CRO3, sir.
Very nice, very nice. PCC. ஒன்னு ரெண்டு பேர் தான் சொல்றீங்க, அதுக்கப்புறம் யாரும் சொல்ல மாட்டேங்கிறீங்க. படிக்கலையா? ட்ரை பண்ணுங்க. So PCC, PDC,
CRO3, sir.
என்னக்கண்ணா?
CRO3 also we can use, no, sir?
Yeah, CRO3 also we can use. Chromic acid also we can use. இதெல்லாம் யூஸ் பண்ணீங்கன்னா என்ன கிடைக்கும்? You will get formed aldehyde acid. Say for example, suppose if I use here like this, OH. What is the name of the compound? What is the name of this compound? Anybody? சிம்பிளான காம்பவுண்ட் தானக்கண்ணா. ஆல்கஹால்ல நேம் நாமென்க்ளேச்சர்லாம் பண்ணீங்க, மறந்துட்டீங்களா?
Cyclohexanol.
Very nice. Cyclohexanol. What about this one? Cyclohexanone. So what kind of reagents I can use, whether oxidizing or reducing? Alcohol to ketone.
Oxidizing, sir.
Oxidizing.
Yeah. CRO3,
you can simply identify. So here one OH is there. Here only O is there. So there will be a removal of hydrogen. Removal of hydrogen is nothing but oxidation. Okay. So I had to use some oxidizing agent. Whenever you want to convert into ketone or from ketone to some other oxidation to carboxylic acid like that, we have to use strong oxidizing agent. Always, if ketone is coming, so you have to use strong oxidizing agent like a KMnO4. If you use KMnO4, so or potassium dichromate, so we can get formed these kind of ketones. Okay.
Sir, we cannot use
next one is
CrO3, sir. Sir, we cannot use
CrO3.
CrO3.
It's a mild oxidizing agent. We can't use it here. So if you want to convert, if you want to make it as aldehyde, you can use it. But for ketone, you should not use it. Then this is what CH3F. Can anybody say what is the name of this compound?
Fluorotoluene, sir. P-fluorotoluene, sir.
3 or 4?
P, sir, or 4 fluorotoluene, sir.
4 fluorotoluene. 1, 2, 3, 4. 4 fluorotoluene or parafluorotoluene. Parafluorotoluene into parafluorobenzaldehyde or 4-fluorobenzaldehyde. How will you make this?
Sir, Itard reaction.
Itard reaction. Very nice. What kind of reagent I can use?
CrO2Cl2, sir.
CrO2Cl2. Chromyl chloride I can use, or otherwise we can use CrO3 anhydride, or otherwise we can use what kind of reagent? Side chain chlorination. Okay, all these things we can use to convert this. Okay, then ethane nitrile to ethanol. How will you make it? Ethane nitrile. CH3 C triple bond N. Ethane nitrile to ethanol. CH3 C double bond O H. How will you make this?
Stephan reduction, sir. Or
Stephan
Dibel.
reduction. Very good.
Or Dibel also.
Yeah, very good. SnCl to HCl I can use, or otherwise we can use Dibol H. Okay, so you have to be very, very careful in these kind of reagents, because in objective type question, definitely you can get many more questions from reagents. Okay, so what kind of reagent, what kind of product, likewise they will be asking. Okay, this time the question paper will be tough only. ஈஸியா இருக்காது, எல்லாமே படிச்சவனும், அதான் பிரச்சனை. எம்சிக்யூ நினைச்சிட்டு ஈஸியா விட்டுறாதீங்க. யூ ஹேவ் டு ஸ்டடி கம்ப்ளீட்லி, கம்ப்ளீட் கான்செப்ட் கம்ப்ளீட்டா படிச்சா மட்டும்தான் யூ கேன் ஏபிள் டு ஆன்சர். ஸோ அதனால தரவா படிங்க. ஏன்னா நம்ம கெமிஸ்ட்ரி பொறுத்த வரைக்கும் எப்பயுமே 1 மார்க் தான். ஸோ அதனால ப்ராப்ளம் இல்லை. ஸோ அவங்க அப்ஜெக்டிவ் டைப்பே வச்சாலும் நமக்கு, டிஸ்கிரிப்டிவே வச்சாலும் நமக்கு என்ன கொடுக்க போறாங்க, 1-1 தான் கொடுக்க போறாங்க. ஸோ அதனால நமக்கு பிரச்சனையே கிடையாது. Okay, and next one is properties of aldehydes and ketones. Properties of aldehydes and ketones. Properties of aldehydes and ketones. So what are all the properties? First property is physical state. Physical state. Usually here, physical state in the sense, the first one is methanol, the first compound of aldehyde, methanol, that is HCHO, that is formaldehyde, is the only gas. Okay. Apart from this methanol, everything is a gas, liquid. Okay, and methanol is a liquid gas at the room temperature. Even at room temperature, this methanol will be a gaseous one. So even ethanol is a liquid. Okay, so 2 carbon containing aldehyde is a liquid. So what about ketone? What about ketone?
Solid, sir.
Yeah, it may be liquid or it may be solid. So we used a 3 carbon containing ketone because if we want to form a ketone, what is the minimum number of carbon required?
3.
Yeah, acetone. It will be using as a good solvent, or propanone. It will be acting as a good solvent. It's a liquid in state. So if you go with the higher ketones, higher aldehydes, even that may be exist in the form of solids also. Okay, very higher ketones. higher aldehydes and ketones or solid salts. Solids are kuda irukirukana possibility. Okay. We already discussed about this concept, boiling point. யாராவது ஒருத்தர் சொல்லுங்க பார்க்கலாம், boiling point அப்படின்னா என்ன? Anybody? யார் வேணா சொல்லலாம். Open choice.
So it's energy which is required to break the intermolecular force of attraction.
Very good, very good. Break the intermolecular force of attraction. Very good, nice. Any other thing? Where is our definition? யாருக்கு தெரியும்? அந்த மாதிரி different participation கொடுங்க.
Temperature at which compound turns from solid to liquid.
Solid to liquid. Solid to liquid is melting.
Liquid to gas. Liquid to
liquid
gas.
to gas.
Solid
Liquid
to
to vapor phase. Very good, very good. Okay, very good. Any other definition? நம்ம ஆல்ரெடி சொல்லியிருக்கோம். Very good. இந்த மாதிரி participate பண்ணுங்க. I will be very happy. Any other definition?
So the vapor pressure of the substance
That's it.
will be
That's
equal
it.
to the
That's what I'm
atmos-
expecting. Yes, yes.
vapor
Once
pressure
more.
The
will be
vapor pressure of
atmospheric.
the liquid phase is equal to the atmosphere.
Very nice. So the vapor pressure of liquid, which is equal to atmospheric pressure, then the liquid started to boil, because here just I'm taking a water, and here just I'm taking a petrol. We already discussed about the same example, I think so. So here, if you use water, if you use petrol, which one will have a higher boiling point? Which one has higher boiling point?
H2O, sir.
H2O. Why?
Sir, hydrogen bonding is there, sir.
Because of hydrogen bonding. Okay, hydrogen bonding is existing. That's what the force of attraction to be broken, we need to give more amount of energy. That's what the boiling point will also be very higher. So when it reaches atmospheric pressure, very later only, it can easily reaches atmospheric pressure, because it's already volatile one, so it can already easily get evaporated. It can easily reach 1 atmospheric pressure here. So it reaches 1 atmospheric pressure means it started to boiling. But here, if you heat this only, this will started evaporating. After that only, the more amount of gases will be in the form of vapor. So when the vapor pressure, which is going to become equal to 1 atmospheric pressure, then the liquid started to boil. That is what the boiling point is there. And here, boiling point of aldehydes and ketones. Boiling point of aldehydes and ketones, or higher than that of hydrocarbon, ethers, etc. Okay, hydrocarbon, ethers, etc. So at the same time, the boiling point of alcohol, is higher than that of aldehydes and ketones. Okay, so the ketones are in mid position. If you taken the compound like this, suppose if I'm taken alcohol has higher boiling point. After that, aldehyde, then aldehyde ketones will be there. After that only, what about that? These are all the things: hydrocarbon, ethers. Okay, ethers, hydrocarbon, like that. Okay, so this is placing a mid position. Aldehydes and ketones are having mid position between that alcohol as well as ethers and hydrocarbon. Okay, why? What's the difference between these things? Because there is no hydrogen bonding existing. Say for example, if I'm taken alcohol, CH3OH is there. One more CH3OH is there. So whether it can form hydrogen bonding? Whether it can form hydrogen bonding? whether alcohol has tried to form hydrogen bonding or not. What do you mean by hydrogen bonding? Anybody? யாராவது ஒருத்தர் hydrogen bonding na enakana?
Interaction between hydrogen atom.
Okay, hydrogen atom.
So the hydrogen atom will be bonded to an electronegative atom of
Very
another
nice.
form.
Very nice. That's it. That's it. Avladha. Hydrogen which is placed in between two highly electronegative atoms. And hydrogen பாருங்க யாருக்கு இடையில இருக்கு இங்க highly electronegative oxygen இங்க highly electronegative oxygen. So if hydrogen is placed in between two highly electronegative atoms such as oxygen, nitrogen, fluorine. இந்த மூணு மட்டும் தான் hydrogen bonding form பண்ணும். Remaining does not form any hydrogen bonding. Even HF will form hydrogen bonding. HCl is not, because the difference between the electronegativity is somewhat less when compared to HF. That's what does not form any hydrogen bonding. It can try to form hydrogen bonding. So only oxygen, nitrogen, fluorine. I gave a clue also like on and off. You just remember it as on and off, on and off. Oxygen, nitrogen, fluorine. Okay, so we discussed about the many possibilities also. Okay, oxygen, nitrogen, nitrogen, fluorine, oxygen, fluorine, nitrogen, fluorine. So likewise, we have many options over there to exist between the hydrogen bonding. So the hydrogen bonding should be formed between two highly electronegative atoms. If hydrogen is placed in between two highly electronegative atoms, then it forms hydrogen bonding. So boiling point is nothing but somebody says that what is that? The breaking of intermolecular forces. What about the intermolecular forces? What are all the categories are there? Intermolecular forces. IMF. You know that IMF, intermolecular forces. What are all that? We have many forces. Like very nice. London force. Good. London force. Then any other thing?
Dipole interaction.
Very good. Dipole interaction. What about that? Next one, hydrogen bond. Okay. So which one is a very weak one?
Dipole, sir.
London force is a very weak one. After that, dipole interaction. Strongest force among these three is what? Hydrogen bonding. So if the bond is very strong, we need to break it very hard. Because we are in need of more temperature to break the bond between that. That's why the hydrogen bonding is existing. The boiling point will be higher. So alcohol has higher boiling point due to hydrogen bonding. But the same hydrogen bonding will not be existing in aldehydes and ketones. Aldehydes and ketones are as only dipole interaction. There is no hydrogen bonding between them. If two aldehydes means what is the intermolecular forces? How the breaking of forces? One molecule of alcohol, another molecule of alcohol are taken. So if two alcohols would be taken, between them, between the two molecules, that is what is the intermolecular forces. Inter means between. Molecular forces. So between the two molecules, some force is existing. That is called the IMF. This force is called IMF. So many number of molecules are combined to form these kind of huge molecules. Molecules combine ஆயிடும். அப்ப மோலா மாஸ் அதிகமாயிடும். once மோலா மாஸ் அதிகம் அப்படினா van der Waals force of attraction அதிகம், force of attraction அதிகம் அப்படினா boiling point will also be very high. But here hydrogen bonding is existing. That is what a higher boiling point will be there. But here dipole interaction. So suppose if I'm taken to aldehyde, so there is no hydrogen bonding is existing. Say for example CH3C double bond O H. And another molecule of aldehyde and CH3C double bond OH. Any chance of forming hydrogen bonding between them?
No, sir.
Any chance of forming hydrogen bonding between them?
No, sir.
No, why?
So because
H is
carbon
not
is
between.
Yeah, because the hydrogen is not attaching with stronger electronegative element. It is not attaching with stronger electronegative element. It is attaching with the carbon in both the case. Right? Now, this carbon is getting positive charge. This will get negative charge. Likewise, this will get negative charge. This will get positive charge. Now, the force of attraction between them are existing. This is called a dipole-dipole interaction. Dipole-dipole interaction is existing. For the ketone also same case. CH3C double bond O CH3. Here also CH3C double bond O CH3. So here some positive charges are there. Here negative charge. Here positive charge. Here negative charge. For this carbon. For this carbon. Now the positive charge and negative charge will be getting attracted. It also try to form dipole-dipole interaction. This is also dipole-dipole interaction. There is no hydrogen is placed between highly electronegative atom. There is no hydrogen bonding. If there is no hydrogen bonding, means the bonding is very weaker, so we can easily break it. So we are not required much amount of energy to cleave the bond or break the bond. That is what the boiling point will be lesser for ketones as well as aldehydes. And we know that suppose hydrocarbon, only hydrogen carbon is existing. So there is a weak van der Waals forces or weak London forces. Weak London forces of attraction will be there. So this will be very weak, very, very weak. So we are not need of any higher amount of energy to break the bond between two hydrocarbons. So it is very little amount of energy required to break the bond. So that it has very, very lesser boiling point. Okay. Say for example, if suppose the compound will be given like this, CH3, COH, HCH3. Propanol they were given, CH3, C double bond O, CH3. Propanone they given, CH3, C double bond, sorry, CH2, C double bond O, H will be taken, and CH3, C, CH3, H, yeah, okay, CH3 will be taken, okay. So, which one has higher boiling point among these four?
Sir, propan 2 all, sir.
Propan 2 all, very good. This one has higher boiling point. So let us assume this is 1, this is 2, this is 3, and this is 4. Okay. Now you can tell me what is the order of that. First one is first. Am I right? Alcohol has higher boiling point among this thing. So number 1 has higher boiling point. What about the second one? Second position placed by?
Sir, 1, 2, 3, 4 order, sir.
1, 2, 3, 4 order. Sure.
So ketone has more boiling point than aldehyde, no, sir?
Ketone has more boiling point than aldehyde. Yes, very good. So 1, 2, then 3, then 4 is high order. Okay. Why ketone has higher boiling point than aldehyde?
Sir, because hydrogen is bonded 2 times there, sir. Either side hydrogen is present with carbon, sir.
Yeah, both the side carbon is there. It can donate electron. It can get more stabilized. That means the ketone is more stabilized when compared to aldehyde, because in to the carbonyl carbon, only one side electron donating group is there. Okay, but here hydrogen is there. That's what it will not be much stabilized when compared to ketones. But what ketone has higher boiling. Okay, very good. Super. Suppose, and next one is next property, solubility. How you know about the solubility? Whether aldehydes and ketones are soluble in water. So solubility here, what is the meaning of solubility? Means we are talking about only the solubility in water. Okay, If aldehydes are taken, whether it is dissolved in water, if it is dissolved in water, then the solubility is more. Okay. If it is not dissolved, it is insoluble. Usually lower aldehydes. Lower aldehydes are soluble in water. Soluble in water. Lower ketones are also somewhat little solubility is there. Lower ketone means a 3 carbon containing ketone like acetone, propanone. Slight solubility is there. Solubility depends on these factors, right? Say for example, R, C, double bond O. Here R is there. Okay. Suppose a water molecule is there. H, O, H is there. And here also R, R, C, double bond O, R. So in both the sides, just I have taken a ketone. Now, if there is any possibility to form hydrogen bonding with water, if there is any other possibility of forming hydrogen bonding between water and aldehyde ketones?
No, sir.
No, sir.
No. Why? There will be hydrogen bonding is existing. Oxygen. Now hydrogen is placed in between two highly electronegative atoms. Here, hydrogen is placed between two highly electronegative atoms like oxygen. Here also oxygen. Here also oxygen. Here also oxygen. So when two ketones are reacting, when two ketones are there in the mixture, or if ketone is taken, there is no formation of hydrogen bonding between them, but it forms hydrogen bonding with water. If two ketones are there, it's RCOR. So in boiling point itself, we discussed about that RC double bond R. Here also RC double bond R, just I'm taken. So here it has slight positive, slight negative, slight positive, slight negative. Here there is no chance of forming hydrogen bonding, only dipole-dipole interaction between the two ketones. But now one ketone is water, which forms hydrogen bonding. That is what it is slightly soluble in water. So there will be a little solubility is there in for lower aldehydes and ketones. Okay. So higher members generally insoluble. Higher members insoluble. Are you able to understand this concept? So this is very, very important because the boiling point is entirely different from solubility. So solubility, for that solubility we used water. Now there will be a chance of forming hydrogen bonding between water and ketone. But in the case of earlier case, a boiling point, we are not going to use any water. That's what only between the two ketones are there. Between the two ketones, there is a force of attraction be existing. That force is called dipole-dipole interaction. But here there will be a hydrogen bonding is existing. When compared to hydrogen bonding and dipole-dipole interaction, hydrogen bonding is a strong force of attraction. Moreover, it can try to dissolve in water. Is that clear or not?
Yes, sir.
Okay. And higher members. So why higher members are insoluble? Why higher members are insoluble? Even though it forms a hydrogen bonding, why higher members are insoluble? If hydrogen bonding is existing, that should be more soluble in water. But here, hydrogen bond is existing, even though it is insoluble for higher members. Why? It's very simple. If the chain length increases, solubility generally decreases. So the chain length, here we have taken generally as R. That R may be CH3. If it is a CH3, it may be soluble. If it R may be C2H5, maybe or may not be soluble. If R will be taken as C3H7, then definitely it not be soluble. Okay, so as the chain length increases, the solubility decreases. Chain length is inversely proportional to solubility. We already discussed in 2 chapters. Same concept we discussed. So sorry, in 1 chapter. What is that? Alcohols chapter we discussed the same thing. So chain length is inversely proportional to solubility. So lower members are soluble in both water as well as in organic solids. So this is also a very important condition. Lower members soluble in, lower members are soluble in water and organic solvents. Even organic solvents also they are dissolved. And the higher members, for higher members, it is insoluble in water. Insoluble in water, but soluble in organic solvents. Organic solvents. What kind of organic solvents? It may be benzene. Very nice benzene, otherwise some chloroform CHCl3, or otherwise carbon tetrachloride CCl4, even ethers. So likewise, these kind of solvents we can use, okay, to dissolve what is that aldehydes and ketones, because they're all some non-polar solvents. So these are all not going to become a polar one. So that's what it is, soluble in organic solvents also. And next one is a odor. Odor. So usually lower aldehydes and ketones, they are pungent in smell. Pungent smell. What do you mean by pungent smell?
Stinky, sir. Stinky kind of thing.
Sorry?
Stinky kind of thing, sir.
Okay, good. The ammonia smell.
Got an eggshell smell.
Ammonia smell பண்ணிருக்கீங்களா எங்கயாவது? Ammonia smell அவ்வளவு harsher, harsh smell. Simply we can say a harsh smell. Harsher இருக்கும். Even dangerous to our nose also. Even we usually used in laboratory we used to prepare ammonia. That ammonia, if you inhale somewhat stronger, you can get blood from your nose. So that kind of strong pungent odor will be. Okay, so strong odor or a strong smell or harsh smell we can say. Higher members, where we are using in body sprays, then scent fragrant, so they can use for fragrance. So artificial fragrance will be generally aldehydes and ketones. Even நீங்க அசிட்டோனை எடுத்து பாத்தீங்கன்னா லைட்டா ஸ்மெல் இருக்கும், பிடிக்கும் உங்களுக்கு. இந்த நெயில் பாலிஷ் ரிமூவர் இருக்கு இல்லையா, அந்த ஸ்மெல் பிடிக்காதவங்களே இருக்க மாட்டாங்க. நெயில் பாலிஷ்னுடைய ஸ்மெல் பிடிக்காதவங்களே இருக்க மாட்டாங்க. ஸோ இட்ஸ் நதிங் பட் அ ஃப்ராக்ரன்ஸ் ஸ்மெல் இருக்கும். ஓகே, ஸோ அது வந்து நம்ம நோஸ்க்கு வந்து ஒரு அந்த இரிட்டேட்டபிளாலாம் இருக்காது, ரொம்ப சாஃப்டான ஸ்மெல்லாக இருக்கும், அந்த மாதிரி இருக்கும். ஸோ அதெல்லாம் இங்கே ஃப்ராக்ரண்ட்டாக யூஸ் பண்ணும். ஓகே, now I can give you some things, you can solve it now. CH3, CH2, CH2, CHO. I can take butanol. CH3, CH2, CH2, CH2OH. Butanol. C2H5O, C2H5. What is the name of this compound?
Diethoxy ether, sir.
Diethoxy ether. Diethoxy ether னு சொல்ல முடியுமா?
Ethoxy ether, sir.
Ethoxy ether கிடையாது, இது ethoxy. அப்ப இது என்ன? ஈத்தேன். ethoxy ethane or otherwise diethyl ether. You can say diethyl ether, that's a common nomenclature. If you said ethoxy, that coming under IUPAC, then you can give the name of ethane. Okay, CH2, 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 CH3. Okay, so now you can tell me the boiling point order. யாருக்கு அதிகமா இருக்கும்? You take this as a compound 1, this is compound 2, this is compound 3, this is compound 4. இந்த நாள்ல யாருக்கு boiling point ரொம்ப அதிகமா இருக்கும்?
Sir, 2, 1, 3, 4, sir.
2, 1 agana 1. Okay, then 3,
3, 4.
Very good.
3, 4,
3
sir.
then 4. Yeah. ஏன்னா இங்க என்ன force of attraction இருக்கும்? Here it has only hydrogen bonding in alcohols, right? And what about these two things?
Dipole.
Dipole interaction. When compared to ether, what is it? Aldehyde has some higher dipole interaction. That's experimentally proved. And what about this one? Weak van der Waals force of attraction. Weak van der Waals forces of attraction. That is somewhat very weak. So based on force of attraction also we can arrange it. Okay. So boiling point order we can say that. Okay. Okay. And next one is a very interesting and important topic. So definitely you can expect more question from this topic. That is nucleophilic. So in chemistry, nucleophilic addition reaction most probably taking place in aldehydes and ketones. Okay. Nucleophilic addition reaction. Addition reaction. Say for example, just I'm taken a ketone, some ketone. Here A, something, some B like that. One nucleophile is there. I just put Nu minus. Okay. Now it has a chance to attack this carbon. If it attacks this carbon, the carbon has getting 5 bonds. So it can cleave this bond to make that oxygen more electronegative. Then A, and here CO minus, and here B is there. In the second step, there will be a chance of adding electrophile. So once the electrophile is getting added, what will be my product? So here a nucleophile is also attached to nucleophile. And here A, C, and here carbon it is B. And here it is nucleophile. And here it is OE. Okay, OE. So in the first step, nucleophile is getting attacked. In the second step, electrophile will also getting involved attack. Why? Why the electrophile will be attacking here? Because we can't take nucleophile as it is. We should be taken in the form of compound. Say for example, HCN I have taken. So what is a nucleophile here? CN minus. We can't take alone CN minus. We should take as HCN. The HCN will acting as a electrophile. That will be involving in the second step. In the first step, the nucleophile is very strong. It will be involving in the attack in the first step. Then after getting a negative charge, the electrophile will again come and approach to form a bond. This is a one way of nucleophilic addition reaction. Another way is what? Just 1 minute, I'll finish it. So here same A and carbon double bond and B is there. And here I have taken Nu. Can anyone say Nu minus Nu? What is the difference between these two? Nu minus and Nu. What is the difference?
Substrate, sir. The substrate, sir.
Okay. Both are same. Both are substrate only. This is a substrate, not substrate. This is a nucleophile. Both are nucleophiles, but if it has a charge, it will be acting as a strong nucleophile. There is no charge, it will be acting as a weak nucleophile. So here our nucleophile is weak. We know that nucleophile is weak. Then in the first step, electrophile will approach. In the first step, if the nucleophile is very strong, it started initiating the reaction. If the nucleophile is weak, the H plus electrophile will approach this. Where it will approach? We know that here it is like positive charge, here negative charge. Then A, then here C, O minus is there, and H plus is getting attached to and B. We know that here positive charge is existing. Now in the second step, nucleophile is weak. So here there will be a positive charge. Now the nucleophile easily come on approach to form a bond between them. So here also, what will be my product? Same product. I can get A, C, O, H, and here also B. We know that here also nucleophile. So instead of, suppose if I'm taking instead of this E plus, if I'm taken H plus, what will be my product? My product will be H. Okay. So here in first reaction, second reaction, products are same, but the reaction mechanism is different. Reaction mechanism is different. In the second reaction, there will be a formation of carbocation. After that, only the nucleophile will come and approach, because the nucleophile is very weak. It's like to be a what is that? You can say SN1 Mari. SN1 reaction, nucleophile is weak. After forming a carbocation, it will come and approach. But SN2, first reaction, it is SN2. SN2 mar nadako. It's not SN1, SN2. It's addition reaction. It's not substitution reaction. It's addition reaction. That's for the examples. Yeah. So by H plus will come and approach here, then it form product. Here, second step, nucleophile will come and approach here. It can also form a product. Same product will be getting formed. So we'll discuss in next class how the nucleophilic addition reaction will be taking place. It's a very, very important part of that this chapter. Okay. Thank you. Remaining at the class part. Okay.
Thank you, sir.
Thank you, sir.
Thank you.
Yes, sir.
Thank you.
Yes, sir.